Bismillah ar-Rahman ar-Rahim. So we'll finish the subnetting for IPv6. And as we said last time, subnetting for IPv6 is exactly the same, and it's supposed to be a little bit easier actually. So we just need to be careful with two small rules. The first thing is that here we're dealing with hexbits, so we need to calculate these bits. How many bits are for subnet and how many bits are for the interface ID, based on the 128 address, and based on the fact that each hexadecimal digit takes 4 bits. The other simple thing that you need to pay attention to is that there's no broadcast address for each subnet. There's one special address for all node multicast, which we have talked about, in which case the number of valid interface addresses is based on the number of bits, and it's 2 to the power the number of interface ID bits minus 1, not minus 2. صح? Because we don't have broadcast address as part of each subnet. Okay? So we need to subtract only one, which is the subnetwork address. So the subnetwork address is not a valid interface address. This is clear. But all ones here is a valid interface address. So that's the only thing that you need to pay attention to. Okay. So the subnetwork address is not a valid interface address. Right? Subnetwork address, similar to IPv4. Okay? If we put the interface ID part, which in IPv4 was called the host part, right? If we put this all ones, that's a valid interface address. It's not a broadcast address. Okay?
Yes.
Therefore, for each subnet, the number of valid interface addresses is actually 2 to the power. These number of bits minus 1, not minus 2.
Okay.
Mafhum?
Yes, mafhum.
So with that said, we just need to calculate the subnetwork address, which combines this part. This part is fixed from here, right? So this is these 3 hexbits are assigned here, okay? And we just need to loop on the interface, the subnet ID part, starting from zeros all the way to all ones, okay? And calculate this subnetwork address here. Then put the interface ID part to 1 to calculate the first interface ID, the first interface address, sorry. And then put the interface ID all F's or all ones to calculate the last valid interface address. Okay? So that's what we need to do here. And we need to do this, we're not gonna list all the subnets. How many subnets do we have here? How many subnets?
20.
Huh?
20.
20 subnets?
2 to the power.
2 to the power.
2 to the power 20. We have 20 bits assigned for the subnet ID. So we have 2 to the power 20 different subnets. Of course, we're not going to list all of them. But we just need to make sure how we calculate the subnetwork address by listing few of them. Okay? And then this first interface address is by setting the interface ID to 1, and this is to set it to all F's. So in terms of method, it's the same like IPv4. Exactly. Here we're just dealing with hexadecimal as opposed to decimal. And here we can put all F's to represent the broadcast, to represent the last interface address, because it's not a broadcast address. Okay, so here it will be 2001 DB8 ACAD, and then here it will be 0. This is actually 4 zeros, and then colon 1 And now the subnetwork part is done. And then the interface ID will have to be all Fs. So the first one is 3 Fs, and then all Fs. Okay? All right. So the next one, all we need to do is just to set this to 2, 3, 4, all the way to F. When we set this to F, this will be 0, and this will be the same. Okay? And the rest, طبعا F 0, 0, 0, colon. Fine? And then here, this will be, again, colon 1, the same thing, colon 1, and this will be F, 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 and then all Fs. The next one, we'll have to add 1 on the subnet ID. When we add 1 to the subnet ID, this F will become 0. And then this hextet will have 1 on the right-hand side and 3 zeros on the left-hand side, so omitted. And then this part will be the same. And then the rest will be all zeros. Okay? So when we set it all zeros, so this will be colon, right? /68. Because the 0 now is part of the next hextet. So 0, and then the subnetwork address is to set the interface ID to all zeros, which means that this hextet will be 0, 0, 0, 0, right? And then the rest is all zeros. So we can easily replace all of them by 2 columns next to each other, right? And then here it will be this same address here is 1, and remember here there will be 0 here on the left hand side, right, for the subnetwork ID, and 3 Fs, and then the rest is all, right? But here there will be 1 on the hextet. Okay, type next. This will be 1, and this will be 1, 0, 0, 0. So we'll keep doing this all the way to F. And this is 1. When we recycle, so this will be 0 and this will be 2. Yes, and we'll keep doing that. Just remember that here, in this hextet, the left-hand side hexadecimal digit belong to the subnetwork address, not the interface address, not to the interface part. So you have to pay attention to that. So the last valid interface address will always have only 3 hexadecimal digits. Only if the left-hand side is 0, we omit it. But other than that, it has to be 1, 2, 3, all the way to F. Okay? And this belongs to the subnetwork part. And the interface ID part will be all Fs. في أي confusion?
You said only 3 hexadecimal?
Right, because it's 20 bits, so we have 4 bits in the next hextet. If this digit is 0, we omit it. Yes, it's single digit.
If 0?
If 0, omit it. خلاص.
For the network?
Yes, for the network, yes.
We put that up.
Right. The problem here is that you can do it on 2 steps. You can just write the whole address and then abbreviate it. Here I'm trying to, because we have lots of calculations, here I'm trying to do the same, the 2 steps in 1 step. But if you think you will be confused, just put the full address without any abbreviation, and then apply the 2 simple rules that we talked about last time. Omit the leading zeros in each hextet separately. And then if you have repeated zeros all the way, so put column to replace all of them.
How many hextets do we have in the...
8. 8. You're supposed to be able to calculate it. Yani 8 times 16 is 128. The last subnet is going to be F, and then F. Yes. Which is yani 20 bits all set to ones. Yani 4 hexadecimal digits, 5 hexadecimal digits, all Fs.
The last one interface was going to be from the last one to the end.
Right. Exactly. Any questions? I don't know why this exercise takes a really a long time, but it's fine.
Yeah, it's not understand.
Yeah. But as you can observe, the method itself is exactly the same like IPv4. It's exactly the same. We just need to be careful that here, all Fs is a valid interface address. Right? Okay, so this is the end of chapter 9, end of all calculations. So
Any calculations after that?
just very, very slight calculations. It's not as rigorous as the chapter 9 and chapter 8 and chapter 6. So 6, 8, 9 are all heavy calculations. Yeah, 6 كان فيه اللي هو النتورك layer كان فيه الادرسنج وكده. So anyway, so now we are actually going back to chapter 7. However, in the building that we are trying to build, we are going up, right? So we are going to the transport layer, right? So logically we are going up. So as we said, the network access layer provides point-to-point communication or communication between any two network devices, whether this is a router or a switch and so on, between two devices. The network layer provides end-to-end communication between two hosts or two networks, two remote networks, right? The transport layer establishes and maintains conversation or communication between two applications. So if you have a host and another host, so this is a local host and a remote host, each host may actually run multiple applications. So this is, for example, HTTP, which runs on the browser. This is, for example, Telnet. This is FTP. Okay, so this is the host. On the remote side, you have another host with other applications. This could be HTTP. This could be SMTP or email, and this could be messaging services or something like this. The transport layer provides the communication or the conversation between two end applications such that both these applications they use the same protocol. They say the same application layer protocol. Okay, so the transport layer maintains this conversation between two applications running on two hosts. Okay, as part of this, logically, we cannot send the message or the information from one application as one unit. As we said before, we have to do a segmentation. So we have to divide the message into smaller segments. Okay, so segmentation and of course reassembly of these segments on the receiver side is also part of the transport layer. So transport layer does segmentation and reassembly.
On the receiver side.
On the receiver side, well, on the transmitter side, it does segmentation. On the receiver side, reassembly. Okay, type. Now we have the information on the receiving host. This receiving host, as well, similar to each layer we talked about, we need to identify the application. So identifying the application is also part of the transport layer protocol, which means that each application has a logical buffer here. So similar to what we have done from the network access layer, we said that we need a protocol field to point to the higher layer protocol, right? In the network layer, we said that we need to identify the protocol above. Here, we also need to identify the application in the layer above. Okay? So we'll see how this is done.
So there's a field in the transportation layer?
Of course, there are two fields. Yes, one for sending and one for. We'll talk about this. Okay? So this will tell the transport layer protocol which buffer I should send this information to. Okay? So these are the three main things. Establish and maintain conversation, segmentation and reassembly, and identifying the application. The segmentation facilitates the mixing of these segments from multiple applications, which is what we call multiplexing. Okay, so these are the main things. So what we need to do now is to map this definition, this description, to one of these rows of the transport layer protocol. Just mapping, tick, that's it. Okay? Based on this discussion. So dividing application data into chunks, easy. Okay? Used to distinguish each web browser, this is a identifying application. Establishes a connection between two end applications. This is a tracking conversation. Okay? Why don't we define the application, the transport layer protocol role as establishes, lay on a conversation? Why would we say establishes connection? Because
establish and maintain.
well, the transport layer protocol does not necessarily have to establish a connection. It establishes conversation. But when we say establish connection, this means that we have to establish the connection first before we communicate something. Which implies that all transport layer protocols are connection oriented, which is not true. Because we have TCP connection oriented, UDP is connectionless. But UDP still maintains conversation, but not through establishing a connection. Remember? So that's why we say conversation. We can say provide communication between two end applications, that's also possible. But we cannot say provide or establishes connection, because this implies that all transport layer protocols are connection oriented, which is not true. Recollecting, this is a Telnet FTP, they all have separate port. This is part of identifying the application. So this is the way that we identify the application. Each flow or conversation or communication has a separate context. This is also a tracking conversation. And interleaving communications, or this is a multiplexing. Okay.